Hello everyone, very good evening one and all. Welcome to Gate Wallah and welcome to the session. Hi Raj Sarkar, hello Nishu, hello Ashwini. How are you all? Guys, please confirm, am I visible and audible? Am I visible and audible? Please confirm. All good? Thank you Nishu for the response. We are in the lecture number 7 of this data structures series, in which we are discussing about arrays concept, right? And today's topic is circular queue using array. So without any delay, let us get into the session. While in the last class we have discussed about a simple queue using an array. A simple queue using an array. What is a queue? Queue is a first in first out data structure, especially this is a simple queue, right? That means what element we insert first, that element only will be deleted first, right? And in this queue, insertion is done from one end and deletion will be done from the other end, right? And this queue, we are having 4 different forms of queues, we can say, as simple queue, circular queue, double-ended queue, and priority queue. In this simple queue we have discussed in the last class. Hope everyone understood the enqueue and dequeue implementations using an array, right? And today we will be discussing about the drawback of simple queue first. What is the drawback of simple queue? Once we understand the drawback, then we move on to circular queue. In this circular queue, how we can implement enqueue operation and dequeue operation using arrays. Okay? Yes, Nishu, let us try to understand that. So, moving ahead, first of all, when you take a simple queue, what is a simple queue? It is a linear list. When implemented using an array, it is a linear list in which insertion will be done from one end, which is called rear end, and deletion is done from the other end, that is called front end, right? And in simple queue, when we are doing enqueue operation, what was the code we have written? First, we verify whether the queue has sufficient space to insert new element or not. How did we verify it? If rear is equal to size -1, then that is indicating queue is full or queue overflow, and then we just return without inserting the new element, else we insert. Right? While enqueue, this is what we check. And similarly, whenever you are trying to dequeue, we will handle the underflow condition or empty condition. That is, if the queue is empty, obviously we cannot delete anything. When there is nothing, what we can delete? Hence, we check for the underflow condition by checking if front is equal to -1, then we check, we confirm that queue is empty. Queue is empty, and without deleting we simply return. Otherwise we will perform deletion. Right? This is what the code we have implemented. Raj Sarkar, what? I did not get you. If rare is equal to 99, for what we have to write that condition, Raj Sarkar? I mean, in what case we have to write that condition? If the array size, see, while enqueue operation, first we increment the rare and then we will insert the value. First incremented, then we are inserting. And before increment, we are checking whether the queue is full or not. Right? Similarly, in the dequeue condition, first you delete and then you will increment front. After deletion, you increment front here. Here, before insertion, you increment rare here. Right? So as per the implementation we have taken, this is what we check. Like when rare is equal to 99, if the queue size is 100, then also we are inserting. And in the next insertion we are checking. Rare is equal to 99, henceforth you cannot full. That means you can't increment it further. Got it? Got it, Raj Sarkar? At a rare is equal to 99, we are inserting. Okay? Fine. Now, if you observe this implementation, guys, let's say I am doing the insertions like this. Let's say I am inserting 10, 20, 30, 40 and 50. Okay? So I have inserted 5 elements and I am taking the size as 5. So at 0th index 10 is inserted, at 120 and so on. Rare is currently at 4, front is at 0. Okay? Now assume I am trying to delete. So what happened? 10 gets deleted and front will move to 1. Okay? Now observe carefully. Suppose I would like to insert a new element. I have already deleted 10. So is there space for new insertion actually in the queue or not? Is there a space actually in the queue? Yes or no? There is a space because you have deleted 10, right? But when you try to insert 60 now, this code will run. And what it is checking? Rear is equal to size minus 1. Rear is still at 4. So as it is 4 is equal to 4, size minus 1, what it print? Queue is full. It will print as queue is full, but actually there is space. Raj Sarkar, there is space. It is a simple queue. There is space, but still having space, this simple queue does not support. So in the simple queue, the drawback is once the queue is full, until you make the complete queue as empty, no further insertion is possible. Okay, so what is the drawback of simple queue? Drawback of simple queue is that once simple queue is full, until all the queue becomes empty, no further insertion, no element can be inserted. Because if you delete all the elements, while last deletion you will set front and rear to -1. So then overflow condition, when we verify, it will be false, then it again start inserting. But until then rear will be at 4 only, at the last index only. So always, whether you delete 1 element, 2 element, 3 element, 4 elements also, though there are 4 spaces also, if the total size is 5, even n-1 elements got deleted, insertion is not possible. Isn't it? Even n-1 elements you delete, having the size as n, insertion will not be allowed. You should delete all the n elements. Then rear is set to -1 again, insertion would be possible. So we can say, so pore space utilization. Pore space utilization. So what we want actually, when we take a simple queue, once the insertion is done from 0th index till the last, further insertion again should start from 0. if at all there is a space. Okay, no one will push you to insert when there is no space. But the drawback is that when there is a space, once you reach the maximum end for insertion, you should again start inserting from the beginning, which is not possible with the circular queue, with the simple queue. Hence, what we have to understand, so the need is cyclic insertion, cyclic deletion. That means rear and front should update in cyclic manner. That means once they reach the maximum limit, they should again start from the first index. Right. So how rear and front can be incremented, updated in a cyclic manner? How rear and front can be updated in cyclic manner? Now this is the big question. If we can achieve this, then the simple queue turns into circular queue. So how we achieve this? In simple queue, usually what we do to update rear and front, we will increment rear. Rear is equal to rear plus 1, front is equal to front plus 1. This is what we do in the simple queue, right? But with this, starting from first index till last index, this is fine. But after you reach the maximum index, you should again start from the 0, means this will not work. So what you have to do? Modulo increment you have to do. In circular queue, what you have to do? This is called normal increment, just linear increment. But we have to do what? Modulo increment. That means rear is equal to rear plus 1 modulus size. Similarly, front is equal to front plus 1 modulus size. Means once you increment, you should apply modulus operation with the size. This is what we can say modulo increment. Means increment and apply modulus with the maximum size. Yes, Nishu, you are correct. So, will this work in all cases? Means yes. Yes. See, if rear is equal to 0, initially let us say. Now, when you do rear plus 1 mod size, what will happen? 0 plus 1, let size is equal to 5 I am taking. 0 plus 1 mod 5, that is 1 mod 5, that is 1. So rear is becoming 1. Now rear is equal to 1. Now 1 plus 1 mod size, 2 mod 5, the remainder is 2. In this way, rear became 2, rear became 3, rear became 4 also. Rear became 4 also. So when rear becomes 4, 4 plus 1 mod 5. What this value is? 5 mod 5, 0. So rare after it reach the maximum index, again in the next iteration rare is becoming what? 0. That means whatever the cyclic update we are expecting, that is happening with this modulo increment. Same case with the front also, because it is the similar operation we are doing. Understood? So whatever the cyclic updation we were expecting, that happens with the modulo increment, but not with the normal regular increment. Is this point clear for everyone? Pavan, in our 𝐂𝐤𝐬𝐿 CS channel, I mean this is English channel, right? Same way you have 𝐂𝐤𝐬𝐿 CS channel. There our expert Abhishek sir is already teaching C programming on the YouTube. Pavan, you can actually follow Abhishek sir lectures for C programming language, but those classes are happening in our 𝐂𝐤𝐬𝐿 CS EC channel. Okay Pavan? Anyway, thank you for your interest in learning C programming. Is this point clear for everyone? Nishu, Raj and everybody else, please confirm. Clear? Very good, very good. Now let us try to understand how do you check the overflow condition and underflow condition, because we are implementing using array. Array means static memory, fixed memory, compile time memory. So definitely there will be a case of full or overflow, and with whatever you implement, whether you implement using linked list or whether you implement using other data structure, empty condition always will be there, underflow condition always will be there. So how do you check overflow condition? Let us take the circular queue. For better understanding, I will draw in the form of circle, but usually it will not be in the form of circle, dear friends. Okay, just for better understanding I will take in the form of circle. Suppose this is what the circular queue we are having. Okay, let the size, maximum size, let us say it is 5. Okay, and initially front will be, rear will be -1, because we are implementing using an array. When there is nothing in the initial stage, front will be, rear will be -1. Now I would like to enqueue (10). From which end we enqueue? From the rear end we enqueue, but rear is at -1. So what you do? You will increment rare, but how do you increment? With modulo. It is not just simple increment. With modulo increment, you do it. So, rare becomes 0 because minus 1 plus 1, 0 mod 5, 0, and then we are enqueuing. And then we are doing the insertion. Similarly, let's say I enqueue 20. I enqueue 20. Rare becomes 1, and here in the first insertion we should manually set front also to 0 in the first insertion, right? We know that. Now I have inserted 20, rare became 1, front still will be at 0. I inserted 30, rare becomes 2, and then I insert 30. Okay. Now let us suppose now I dequeue. What I want to do? I dequeue. Deletion happens from front end. So we delete what is at front, and then front also we do modulo increment. So front equals to front plus 1 mod size. So front becomes 1. So front comes to 1. Now I do one more deletion. Now front will be, after deleting, front will be 2. So front is at 2. Rear also at 2. Now I am doing the next operation I would like to do is the next operation enqueue. Enqueue 40. So rare is modulo incremented. So rare becomes 3 and we enqueue this 40. Next operation I do is enqueue 50. So rare becomes 4 and I enqueue 50. Now I do further insertion. Now I would like to perform further insertion. I would like to do one more enqueue operation. Now rare will be 4 plus 1 mod size, 5 mod 5. So rare becomes 0, 60 is inserted, and one more insertion I am doing, enqueue of 70, 0 plus 1 mod size. So rare becomes 1 and 70 is inserted. Okay. Now guys, you tell me, now the queue is full or not? Now the queue is full or not? I have 60, 70, 30, 40, 50, front is at 2, rear is at 1. Now the queue is full or not, you tell me? Now the queue is full. That means if I try to perform one more enqueue operation, actually it should not be possible. Here I should get queue is full. Queue is full. Isn't it? So, when such case actually reached, rear is at 1, front is at 2. Rear is at 1, front is at 2. That means, shall I write when front greater than rear, queue is full? No, because if it is a regular insertion, 5 elements we have inserted, front will be at 0, rear will be at 4. Then front greater than rear? No. But still the queue is full, no. So you cannot write front greater than rear. Then shall I write if front is equal to rear plus 1, just front equal to rear plus 1. If that is the case, front is 2, rear plus 1 means 1 plus 1, 2, that is okay. But just assume rear is 4, front is 0. If I write front equal to rear plus 1, 4 plus 1 will be 5. So what I should do? So what is the condition I have to write for checking overflow or full? What is the condition I have to write? If front is equal to rear plus 1 mod size that indicates the circular queue is full. That indicates the circular queue is full. Because now 1 plus 1, 2 mod size, 2 mod 5 is 2, front is 2. So now you can say yes, queue is full. That is correct. So everyone understood how I have to check whether the circular queue is full or not? Yes? Yeah, good. Now, how I check underflow condition? How I check underflow condition? Let us say this is the queue. I am doing the insertions and deletions. Initially front is equal to rear is equal to -1, size is equal to 5. Let's say first I am doing enqueue of 10. We know rear will be 0, queue is 10 is inserted, and then I do enqueue 20, rear becomes 1, 20 is inserted. Now enqueue 30, rear becomes 2, 30 is inserted. Assume now I am doing dequeue operation. Dequeue operation. So 10 gets deleted, front will be 1. one more dequeue operation, delete front is 2, delete front is 2. Now assume I am doing few more insertions, enqueue 40, so rear becomes 3, 40 is inserted, and enqueue 50, rear becomes 4, 50 is inserted. Then let's say I am doing enqueue 60, rear becomes 0 and 60 is inserted. Enqueue 70, rear becomes 1, 70 is inserted. Okay. Now please understand, I am going on deleting the elements. Only deletions now I am doing. So dequeue 30 gets deleted, front becomes what? These are the indices 0, 1, 2, 3, 4. What is at index 2 got deleted and front becomes 3. dequeue 40 gets deleted, front will be 4. dequeue 50 got deleted, front will be 0, modulo increment even for front also. dequeue 60 got deleted, front becomes 1, and dequeue 70 got deleted, front became 2. Now front is at 2, rear is also at 2. Front is at 2, rear is also at 2. Now you tell me, will I be able to do further deletion? Will I be able to do further deletion? And I am doing modulo increment of front after deletion, right? So before I go ahead with the deletion, if I check if front is equal to rear, front and rear if they are same, that means queue is empty. Here front and rear are same. Now the queue is empty. Yes, that is initial. Later I did so many operations, so many insertions, so many deletions. So at certain point, when I have done 7 insertions, 7 deletions, again queue became empty. Again front reaches rear. Right. So when front is equal to rear, at that point we can say queue is empty. Right? But here there is a small problem. Here there is a small issue. What is that issue? Suppose there is only one element. You have inserted only one element. 10 was inserted. Rear is 0, as it is the first inserted element. What do you do? What do you do? Front also you set to 0. Front also you set to 0. Now suppose I would like to delete. After first insertion, I would like to delete. Now if you see, if you check, front is equal to rear. If front is equal to rear, front and rear are same, and it will go on printing queue is empty, but actually there is one element. Actually there is one element. Do you understand, guys? Do you understand what the issue that I have raised here? What's the bug with this? So it should be properly handled. It should be properly handled. Okay? So now if I go ahead with the implementation part, circular queue insertion, 𝐂𝐚𝐿, let's say I am inserting value. Now I check if front is equal to rear plus 1 mod size, then definitely the queue is full. This is a case of overflow. You will not be able to perform enqueue operation, so return. Else you will be able to perform insertion. How? Rear plus plus queue of rear is equal to value. Before you return, you should check if front is equal to -1, set front to 0. Now you can return. But this is a circular queue, no? So what you have to do? Instead of simple increment, you should do rear is equal to rear plus 1 mod size. Right? Now this is enqueue operation. Now what is dequeue? I said if front is equal to rear, when front reached rear, that is a case of underflow, but it works for all if there is only one element, that too the very first element, or when there is only one element, then it may not work. Then it may not work, isn't it? So what we have to do? Think. What we have to do? No, Raj Sarkar, only one statement in the if. In if only this statement is there, and this return is in the else, not inside this if. Okay, so no need of curly braces, it's not mandatory. Okay, after writing certain condition, I will be realizing queue is empty, return. Yeah, else we will be able to perform deletion. How I delete? How I delete? Like you will be printing the deleted value. The deleted value is percentile D, comma Q of front. Okay. Now you will be incrementing the front. Okay. And do you need to do simple increment? No. What you have to do? Front is equal to front plus 1 mod size. Fine. With this modulo increment happens. Okay. If all the elements you are deleting, if that is the last element you are going to delete, how do you know that that is the last element? How do you know that that is the last element? If rear is equal to front plus 1 mod size, so before you are incrementing, what I am checking is if rear is equal to front plus 1 mod size, then that means I am going to delete the last element. Now what I have to set? Front to minus 1, rear to minus 1. Front to minus 1, rear to minus 1. Okay, okay, but here if I write, if front is equal to rear, that will not work, right? So otherwise you will be doing front is equal to front plus 1 mod size. Okay, return. Fine. Now the point is, if I am doing regular deletions, 0 element deleted, rear is at 4, 0 element deleted, front becomes 1, 1 deleted, front 2, 2 deleted, 3, 3 deleted, 4. Now rear is at 4, front is also at 4. So this is actually having some bug. When you are deleting the value which is at index 3, rear is at 4. Now you are checking if rear is equal to 3 plus 1 mod size, then without deleting the last element only, you are actually moving front and rear to minus 1. So this is also wrong. So what to do? What to do here? Definitely I have to do front is equal to front plus 1 mod size. Front equals to front plus 1 mod size. Now what I have to do before I return? Now I am giving this as blank. You think and you fill and you give your answers in the chat box. However, in the if, what I am writing? If front is equal to rear plus 1 mod size, if front is equal to rear plus 1 mod size, I am telling queue is empty. Queue is empty. Oh, sorry. Queue is full. Sorry. If front is equal to rear, I am saying queue is empty. But when front is equal to rear means front also can be 0, rear also can be 0. Then without deleting that value, it will simply print queue is empty. So what I do? Here I write one more condition. And if front not equal to 0, front not equal to 0, again this has bug. So front is equal to rear, and here I should write front should not be 0, rear should not be 0, because there it will not work. Or there could be other ways. I am just writing the brute force method. Okay? Now your homework is, I have to write something else here. What I should write? You check. You tell me what I should write. Okay? All right. So that's all for today, guys. Yeah, that is what Nishu. Anyway, today we understood what is the drawback of simple queue and what is a circular queue and how we update front and rear in the circular queue and how we implement using array. Right? So I believe everything that we have discussed so far is clear for you in today's class, and I have given a small assignment, small homework for you. Before you give the final answer in the chat box, or you be ready with the answer for the next class, you check yourself multiple times whether that works in all the cases or not. Okay? Thank you so much, guys, for attending the session and attending regularly. See you tomorrow sharp at 7 p.m. and tomorrow we will be discussing priority queue implementation. Okay? Thank you all. Good night, everybody. Take care. Bye-bye. Jai Hind.